Right, question number 13 is a probability tree diagram question. Rashid drives his car along the road, passing through two sets of traffic lights. The tree diagram shows the probabilities of the lights being red when he reaches them. So what you have to recognise here is that in the first part, for part A, you need to complete the tree diagram. Really simple, one mark. You know, or you should know, that these two numbers, this one and this missing one here, have to add up to a whole number. They have to add up to 1, because these two events are mutually exclusive. You can't have a red light and not a red light at the same time. So therefore, the missing value is 0.4 in this instance, because that would make 1 if you added those together. Same reasoning applies here. So 0.7 and 0.3. And same reasoning applies here for these two branches, 0.2 and 0.8. There we go. So we've completed the tree diagram. We now need to write down the probability that the first set is not red. So the probability of the first set not being red, there we go, 0.4. Nice and simple. That's the probability the first set is not red. We've written it in there. Interesting that we're getting a mark for that, having just written that on the tree diagram. Strange question. There we go. C. Given that the first set is red, write down the probability that the second set is not red. So we now have to follow the branches. So the first set is red. So I'm going to follow this branch and we're going to go this way and then not red. So we're going to then go this way. Right? So the probability of red and not red is equal to, and then the key to answering these questions is you need to remember you multiply the probabilities together, multiply across the branches. So 0.6 times 0.7, 0.6 multiplied by 0.7 is 0.42. And you can use your calculator if you want to. Just being a bit lazy because I don't like that calculator. So 0.42, nice single mark, nice and simple. Work out the probability that both sets are not red. So again, we're just following this strand, not red strand, and not red again. And again, exactly the same bit of working out. Another mark, so not red is equal to 0.4 times 0.2, which is, and then if you multiply both numbers by 10, you get 8, and then you're going to divide by 100, so 0.08 is our answer for that question. 2 marks for that one. Not sure why. Okay. E, work out the probability that at least one set is not red. So that's a weirdly worded question. Work out the probability that at least, there's the key bit of terminology there, one set is not red. So in what ways are we getting one set that is not red? So it's probability of red, red. We've already worked out some probabilities here, so this will help us. So probability of red, red is equal to 0.6 times 0.3. Okay, if we multiply those two together, we get 0.18. And then the probability of it being not red and then red, so probability not red and then red, is equal to, and you can do this working out any way you want, I'm just doing it next to the strands because it's a bit easier and we've got the space to do it in. So 0.4 times 0.8, and that equals 0.32. Now read the question carefully again. What's the probability that at least one set is not red? So at least one set is not red. We've got red, red, so 0.18. I'm going to write all these probabilities down. We've got red and not red is 0.42. And we've got not red and red, which is 0.32. So they're the 3 ways that we could have at least one set that's not red. So we're going to go 8 plus 2. We can just use our calculator again to add these up if we want, but that's 12. And then that is 5, 8, 9. And then 0.92. So you add the probabilities at the end. If there's a question like this, you could have worked out the probability of it being not red, and taken that away from 1, which might have been a bit easier. 0.08 minus from 1 is 0.92. So there's your final answer, 0.92. Nice probability tree question. 13 is about Rashid driving his car along the road, passing through 2 sets of traffic lights. And we've got a tree diagram that shows probabilities of the right lights being red when he reaches them. So the first set has a probability of it being red of 0.6. And in part A, we need to complete the tree diagram. So knowing that these two events are mutually exclusive, i.e. you can't have a light being red and not red at the same time, so they're mutually exclusive, these two probabilities have to add up to 1, so that number must be 0.4. And the same logic applies for the second set of traffic lights, 0.7, so chance of it being red is 0.3, and then same logic again here, 0.2 not red, so 0.8 is the chance of it being red this time round. So the tree diagram has been completed, 1 mark for us there. Part B, write down the probability that the first set is not red. So looking here, first set, not red, 0.4. Strange that that gets us another mark, considering we've just filled it on the tree diagram, but there we go. C, given that the first set is red, so the first set being red here, what is the probability that the second set is not red? So not red, 0.7. Another single mark available for us there. Very quick to get those marks. Read that one carefully. You might get that a bit confused, but given that the first set is red, write down the probability the second set is not red, follow the red, follow the not red, and then write the probability down. By the way, we could be given our answers as fractions here. If you want to convert them to fractions because you prefer fractions, that's absolutely fine. Decimals, percentages, acceptable, they're all the same thing. So D, work out the probability that both sets are not red. That means we now have to start following the strands. Not red, not red. So if we follow the strand, 0.4 and 0.2. The thing to remember is that you multiply across the branches to work out the probabilities. So I'm going to write that next to it here. Probability, not red, equals 0.4 multiplied by 0.2. Now that equals 0.08. If you want to get your calculator out and do that, that's absolutely fine, but 4 times 2 is 8 and then divide by 100, nice and simple. So answer to that question, 0.08. You could do the working out in this space here, but it's nice to do it next to the strands on the probability tree, and we've got room to do so. So part E, you've got 3 marks for part E. Work out the probability that at least one set is not red. At least one set is not red. So confusing way of writing this, really irritating that they would write questions in this way. It just makes your brain go what. But if you think about it carefully enough, work out the probability that at least one set is not red. We're excluding the red. Okay, that's the one we're not interested in. We don't want that one's probability. So we've already worked this one out. If we work this way out, the fact that it's not red and then red, probability not red and then red, we've got 0.4 times by 0.8, which is 0.32. You could write all the workings out down just to make it a bit quicker. And then red, not red, probability of red and not red is equal to 0.6 times by 0.7, which is 0.42. And then you can add these probabilities together. So this, and this satisfies this sentence. So add those together, 0.42. Again, you can get your calculator to do this if you desire. So basically 42 plus 32 plus 8, which is, oops, I didn't mean to write 8 then. I meant to write 0.08. It's because I said 8. So if you add these decimals together, you get 0.82. And that is our probability that at least one set is not red. Because this is where you get 2 not reds, this way you get 1 not red, and this way you get 1 not red. This is the only way you don't get a not red set of lights. So 0.82 is our answer. Cheeky.